Hi everyone, today we're going to study graphs of linear functions. First, let us define linear functions. A linear function is a function whose graph is a line. Linear functions can be written in the slope-intercept form of a line. This is f of x equals mx plus b. We know that m, the coefficient of x, is the slope of the line, and the b is the y-intercept. Showing the ordered pair, we can write 0, b. As defined, y-intercept is the point where the graph intersects the y-axis. Also, there is x-intercept, and that is the point where the graph intersects the x-axis. To illustrate, we have here a line, and with respect to the rectangular coordinate system, this point here is the y-intercept, while this point is the x-intercept. To find the x-intercept, we set a function equal to 0 and solve for the value of x. So, given f of x equals 0, we can have mx plus b equals 0, and this positive b is transposed on the right. The sign is changed, so we have mx equals negative b. Since we want to get x alone on the left side, we will divide this equation by m. So the m here will be cancelled out, only x comes down, and this is equal to the negative b over m. So the x-intercept equals negative b over m. We may use this formula to get the x-intercept. To summarize, the general form of the linear functions is f of x equals mx plus b. The y-intercept, we may write the ordered pair 0 and b. For x-intercept, it has the ordered pair with x-coordinate negative b over m. Take note, this b is that y-intercept over the m, which is the slope of the line. Then comma, 0. How to graph a linear function? We are going to follow two steps. Step 1, find the intercepts. Step 2, draw the line connecting the intercepts. Let's have examples. Find the slope and intercepts, and then sketch the graph of the linear functions given below. Number 1, f of x equals 3x minus 6. So we write the general form of the linear functions here. The f of x equals mx plus b. First, we can collect the slope, which is the coefficient of x, and that is 3. Followed by the y-intercept, which is the negative 6. And if we write this in the ordered pair, it will be 0, negative 6. For the x-intercept, we're going to use this formula, negative b over m. Substituting the values, this is equal to, first, the b is negative 6 over the m is 3. And then this negative and negative becomes positive, and 6 divided by 3 is equal to 2. To show this as an ordered pair, we will write 2, 0. Now, let us sketch the graph. Let us show the x and y axis, and then identify the negative 6 in the y-axis and the positive 2 in the x-axis. Then let us plot the points. First is 0, negative 6, that is the point, followed by the 2, 0, that is the point. And then we will connect the 2 points, and this is now the line. F of x equals 3x minus 6. This is our final answer. Let us have example 2. Let us find the slope and intercepts and sketch the graph of this f of x equals 4 minus 2x. The general form of linear functions is written here. For our convenience, we may rewrite this problem in such a way that the negative 2x comes first. And from here, we will collect now first the slope, and that is the coefficient of the x, which is negative 2. Next is the y-intercept with coordinates 0, 4. You can see I copy directly the constant in the function, and it is written here. Next is the x-intercept. We will follow the formula negative b over m. And substituting the values, this is equal to negative 4, that is the b, over the negative 2, which is the slope. And then we simplify. Negative and negative becomes positive. 4 divided by 2 is equal to 2. Showing now the ordered pair of x-intercept, we have 2, 0. To sketch the graph, let us first show the x and y axis, and then let us identify the 4 in the y-axis and the 2 in the x-axis. Then let us draw first the y-intercept, that is the point, and the x-intercept 2, 0, that is the point. And then we simply connect these 2 points, and this is now the line of the function 4 minus 2x. This is our final answer. Hi everyone. Today we're going to study graphs of quadratic functions. In particular, we will study the general form of quadratic functions. A quadratic function is a function of degree 2. The general form of a quadratic function is f of x equals ax squared plus bx plus c, where a, b, and c are real numbers and a is not equal to 0. By the way, when we say degree 2, the highest power that we can see in the function is square. Let's have examples. This is the first example. F of x equals x squared plus 4x plus 3. With regard to the general form, we can collect the values of a, b, and c respectively for the given function. So in here, the a is 1, that is the coefficient of x squared. The b is 4, and the c is 3. Another example is f of x equals negative 2x squared minus 4x plus 8. Also, the a equals negative 2. The b is negative 4. And the c is positive 8. This is now a fact that the graph of a quadratic function is a parabola. These are pictures of parabola. One is opening up. Another parabola is opening down. Let's begin with a parabola that opens upward. The general form of the quadratic function is here. The f of x equals ax squared plus bx plus c. The properties are here. Number 1, a is greater than 0. It means the a, which is the coefficient of the x squared, is positive. We have the example a while ago. In here, the a is positive 1, and we can say that this function has a parabola that opens upward. Property number 2 is the vertex. This is the vertex, the lowest point of the parabola that opens upward. And the ordered pair of the vertex is hk. The formula for h equals negative b over 2a. Take note, the b here is the coefficient of x, while the a is the coefficient of the x squared. And the k value equals f of h. Property number 3. The axis of symmetry. A parabola has symmetry with respect to a line, and this line is called the axis of symmetry. We can see this is a dotted red line in here. And the formula for the axis of symmetry is x equals h. Property number 4. The domain is all real numbers, and we can write it in the interval notation to be negative infinity, comma, infinity. For the range, these are the values for the y. So this is square bracket k, comma, infinity. Number 6, the minimum value, which is k, equals f of h, or we can simply copy the value that we have from the vertex. We can write here. Number 7, decreasing interval. A parabola has a decreasing interval, and later on we will have increasing interval. If you're going to read the parabola from left going right, the decreasing interval is the left side of this parabola with respect to the line of symmetry. So we can write the interval to be negative infinity, comma, h. And we use the square bracket. Likewise, for the increasing interval, this is the graph, the right side of the parabola, that is the increasing interval. It is going up. And the interval notation for that is square bracket h, comma, infinity. Now let us have the parabola that opens downward. The vertex is now on top. And let's begin with our property number 1. A is less than 0. It means A is negative. A while ago, we have an example f of x equals negative 2x squared minus 4x plus 8. We can see here that the value A, the coefficient of x squared, is negative 2. We can say immediately that the graph of this function is a parabola that opens downward. Let's go to property numbers 2, 3, 4. These three properties are the same properties of the parabola that opens upward a while ago. The vertex is hk, and we can compute the h equals negative b over 2a. Again, b is the coefficient of x, and the a is the coefficient of x squared. Also, the k equals f of h. Property number 3, the axis of symmetry. This is the axis. And the equation is x equals h. Property number 4, the domain is all real numbers, and the interval notation is negative infinity up to positive infinity. Property number 5 is the range, the values for y. So with respect to the y-axis, it starts with negative infinity, and the highest is the k value, and we use the square bracket. Number 6, the maximum value is k, and we can simply copy the value of k in the vertex. We can write here. Number 7, decreasing interval. So the interval from which the graph is going down. So our parabola is opening downward. So the right side from here, it is decreasing. So our interval notation, square bracket, h, comma, positive infinity. For number 8, the increasing interval is the left side of the parabola. It is going up. So our interval notation for the increasing interval is negative infinity, comma, h, and we use the square bracket. Let's have an example. Sketch the quadratic function f of x equals x squared plus 4x plus 3, and find the following: a, vertex, b, axis of symmetry, c, range, d, maximum or minimum value, e, decreasing interval, f, increasing interval. First, let us write the general form of the quadratic function. F of x equals ax squared plus bx plus c. And then, let us collect the corresponding values for a, b, and c in the given function. So a equals 1, b equals 4, and c equals 3. Please note that the a is positive, and we can say now that this parabola opens upward. Now let us start calculating the vertex. We have the formula for the vertex. For the h is equal to negative b over 2a. Let us substitute the values. For the b, it is 4, and for the a, it is 1. So let us simplify this negative of 4 over 2 times 1, and we have the answer negative 2. This is the h. Now for the k, what we will do, we will use this value of h in our original function. It means I'm going to copy the same function down here, but every time there is an x, I will change that by the h value, which is negative 2. So we have the x squared becomes the square of negative 2 plus 4x is now 4 times negative 2 plus 3. We simply copy here. Then we simplify. The square of negative 2 is positive 4 plus 4 times negative 2 is negative 8, and then plus 3. Simplifying this, we have the answer k equals negative 1. It means we will write the vertex as an ordered pair. It is negative 2, negative 1. We will copy this value opposite letter A in here. So we have now the answer for the vertex. Since we have the vertex, we can draw now the parabola. This is now our parabola, and the parabola opens up. Let us compute now for the axis of symmetry, this line here. We have the formula, and this h is simply the negative 2. So we will just replace this h by the negative 2. So we have now x equals negative 2. And this is now the axis of symmetry. For the range, the formula is square bracket k, comma, infinity. This k is the y coordinate of the vertex. So we will just change the k by negative 1. So our range is square bracket negative 1, positive infinity, close parenthesis. So we are done with the range. Now letter D, maximum or minimum value. Since the parabola is opening upward, we have a minimum value. There is no maximum value because the parabola is going up continuously. So the minimum value is that k equals the f of h. No need to compute for this. The k value we can simply copy from the y coordinate of the vertex. So k equals negative 1. So we are done with letter D. Now for letter E, let's have the decreasing interval. The parabola is opening upward. The left side of the graph with respect to the symmetry is our decreasing interval. And our interval notation is negative infinity up to h. So we will just change this h by our x coordinate of the vertex. So we have negative infinity, comma, negative 2, square bracket. So we are done with decreasing interval. Going to increasing interval, that is now the right side of our parabola with respect to the line of symmetry. And the interval notation is square bracket h, comma, infinity, parenthesis. Now this h, again we will change by the value that is negative 2. So it becomes square bracket negative 2, comma, infinity, parenthesis. So this is now the answers for our example. Hi everyone. Today we're going to study graphs of quadratic functions given the standard form of a quadratic function. Let us now identify quadratic function in standard form. The standard form of a quadratic function is f of x equals a times the quantity square of x minus h, then plus k. We know that the graph of a quadratic function is a parabola. In the standard form, we can see here the h and the k, and that is exactly the vertex of the parabola. Also, this a gives a very special idea. The parabola opens upward when this a is positive, or the parabola opens downward when this a is negative. Let's have an example. Sketch the graph of the function f of x equals -3 times the quantity square of x plus 2 plus 4, and find the following. Letter A, vertex. B, axis of symmetry. C, range. D, maximum or minimum value. E, decreasing interval. And F, increasing interval. From the standard form of the quadratic function, as written here, we can collect the vertex immediately. However, let us make sure that the given function must be in the standard form, or we may rewrite the given function into the same way with our standard form, and it will be like this. We are going to copy exactly the same except in this plus 2. Since the standard form is written minus h, we are going to rewrite this plus 2 into negative of -2. And the rest of the function will be same. And from here, we're going to collect now the vertex or the hk values. So this -2 is the h and the +4 is the k. Therefore, the vertex has the ordered pair -2, 4. And then this -3 is the a. And since our a here is negative, it means the parabola opens downward. So let us copy the vertex opposite this letter a, and we will take note that the parabola opens downward here. Then let us clear the right side of the screen. Since the vertex is known, and we know that the parabola opens downward, we can now draw the parabola. So we have a parabola here that opens downward, and the vertex is the highest point. That is now the point -2, 4. Now letter B, for the axis of symmetry, it is the vertical line that passes through the vertex. And our formula is x equals h. And this h is the x coordinate of the vertex itself. So we will just substitute the value. So here the h becomes -2. Therefore, the axis of symmetry is x equals -2. For the range, we have the formula, the negative infinity, comma, k, and we use the square bracket. This k is the y-coordinate of the vertex. So we will just substitute the k. It becomes 4. The range now is negative infinity. Of course, we use the parentheses, then comma, 4, and the square bracket. Now for letter D, maximum or minimum value. The parabola opens downward, so we don't have a minimum value because the graph of parabola goes down continuously. So we have a maximum value here. And that value is equal to the k itself, and this k is that y-coordinate of the vertex. So we have k equals 4. So the maximum value is 4. Now letter E, decreasing interval. With respect to the axis of symmetry, the right side of the parabola is our decreasing interval. Do you remember? We're going to read the graph from left to right, and when it is going down, that is the decreasing interval. So this side here is the decreasing interval. And our formula is the square bracket h, comma, positive infinity, parenthesis. And this h we will now change by the x coordinate of the vertex. So the decreasing interval h becomes -2. So this is now our interval notation for the decreasing interval. For the increasing interval, that is the left side of our parabola. You see here, if you read the graph from left to right, so that is the increasing interval. And we have the formula for that. That is the parenthesis, negative infinity, comma, h, and square bracket. We will just substitute the h value with our x coordinate of the vertex. So our answer is the negative infinity up to -2. We use the square bracket here and also the parenthesis because we know every time there is infinity, always parenthesis is used. So we are now complete with our answers. I hope you learned something from this video. See you again next time.